Hi guys, we are going to work through some model solutions for the COVID assessment. We're going to start off with section 1, which is the pure questions from the first year of the course. Okay, question 1. We have got a function y is equal to 3x squared, 24 over x plus 2, values of x bigger than 0. It's not interested in the negative values of x. We've been asked to find dy by dx, so I need to differentiate each of the three terms of my function. So dy by dx is equal to, got my 3x squared, I'm going to reduce my power by 1, that 2 is going to be brought down, it's going to multiply by my 3, so I'm going to have 3 lots of 2. Let's write that in, so I've got 3 lots of 2, x squared, reduce the power of 2 to the power of 1, don't need to write that 1 in, so I've got 3 lots of 2x, 6x. 24x to the minus 1, so I want to reduce my power of minus 1, so that's going to become x to the minus 2. My minus 1 power is going to come down, multiply it by 24, I'm going to get negative 24 x to the negative 2. Differentiate my constant, that's going to disappear, so I'm just going to be left with the two terms. I can tidy that up a little bit, that's going to give me 6x minus 24 over x squared. I could have left it as minus 24 x to the negative 2, either of those would have been fine, either would have picked up the marks. This question was really generous in terms of mark scheme. To correctly reduce the power of either of these terms by 1 got me a method mark. So to reduce that to x got me a method mark, and then an accuracy mark for both of those two terms. So to get the 6x would have got me an extra accuracy mark, and then either the minus 24x to the minus 2 or minus 24 over x squared, same thing, and that got me my second accuracy mark. So for this question, if we correctly differentiated 3x squared to get 6x, I've got 2 marks, a method and an accuracy mark, which is really generous. 3 marks in total, pretty easy part of the question. Next part says, hence, find the exact range of values of x for which the curve is increasing. The first thing you want to do is have a think about what this curve is doing. So, draw yourself a little diagram. We've got 3x squared plus 24 over x plus 2. If you think about when x is going off to infinity, what's going to go on? 24 divided by x is going to go to 0. This is going to be 2, going to be negligible. My x squared is going to shoot off faster than my x. So it's going to go, y is going to go to infinity. So, don't know what's happening to the left yet, but I know as soon as x is getting large, the value of y is getting even larger, so it's going to shoot off to infinity here. Have a think about when x is 0, well that term's 0, that's 2, is going to be negligible. 24 divided by 0 is going to be infinity, so it's going to shoot off to positive infinity. So my curve's going to be asymptotic at x equals 0, and it's going to come down. Now I don't know at the moment what it does in the middle. It might do something like this and have a bit of a wiggle in the middle. It might just look like a minimum. I don't know. But I know it's asymptotic at x equals 0, and I know it shoots off to infinity as x does. But what we need to do now is have a think about the points where the gradient of that graph are going to be equal to 0. So to work out where it's increasing, let's have a look at where it's neither increasing nor decreasing, and that's when dy by dx equals 0. So just to put my dy by dx, this expression here, equal to 0, gets me a method mark. There's actually only 2 marks available for this part of the question, and I've just picked one of them up already by putting 6x equal to 24 over x squared. Well, I can multiply through by my x squared, so I've got 6x cubed equals 24, x cubed is equal to 4, x is equal to the cubed root of 4. So this bit up here, actually to get down to this bit, got no additional marks, got a method mark for just putting my dy by dx equal to 0. Now I've only got one solution for my dy by dx equals 0. So I've only got one point where my curve is going to be horizontal. So it must look something like a quadratic. So there's one point where this is horizontal. That's at my point, the cubed root of 4. So to finish the question off, it says what values of x, let's read the question. It says for which values of x is the curve increasing? The curve is increasing for x greater than the cubed root of 4. The benefit of drawing my curve is I know it's increasing for these values. So I know I'm looking for x greater than my cube root of 4. This question was in some ways a little bit generous because by coming up with x greater than the cube root of 4, it gave me my accuracy mark. In an A-level question though, it would probably have expected me to justify why I've chosen the values greater than the cube root of 4. So why was I looking for these values rather than x less than the cube root of 4, these values here. So the easiest way to do that is to draw your sketch. If you've got this labelled on, you've got your asymptote, you know it's heading off to infinity here, you've got a single value for which dy by dx is equal to 0, so a tangent down here. So I know I'm looking for these values of x greater than cubed root of 4. If you don't justify that, you just write that down without any form of diagram or without some justification for why you want the larger values, in an A-level question you probably would lose some marks. So always justify it, and the easiest way to do that is the diagram. Two things. One, it's giving you justification for the values that you're picking. Second, it's also helping you to work out what's going on with the question. If you've got that sketch, it's easy to work out what the various parts of the question are actually asking. Okay, let's have a look at question 2. So we've been given a function, y equals k squared over x plus 1. We've been told that x is in the set of real numbers. X is not equal to 0, obviously it will head off to infinity at that point. And we've been told that the value, that k is a constant. So we don't know what it is, k is a constant, and we've been given k squared over x. So we know that we're dealing with a positive multiple of 1 over x. Okay. Part A says sketch C, stating the equation of the asymptote. So first of all, let's have a think about what 1 over x would look like. So 1 over x, or will look something like that. So I'm going to have two asymptotes. I'm going to have a vertical asymptote, horizontal asymptote on my axes. So this is y equals 1 over x. And in fact, this graph would also hold for some multiple above my x. As long as that number is positive, the graph's going to look something like this. So my value, my axis will get stretched if I've got a large value of k over here, but I haven't put any form of scale on here. So my curve would look identical for y equals k squared over x. Remember, if they hadn't told us k squared, they just told us k, we didn't know whether k was positive or negative, I'd only get this for the positive values of k, and I'd get this for my negative values of k, and that really wouldn't help me to draw my graph. So they haven't told us that. They've told us that they're giving us k squared, so we know we're dealing with a positive value, so my curve must be in the first and third quadrants. Okay, now the actual question wasn't k squared over x, it was k squared over x plus 1. So we've actually got a graph transformation question. What we're going to do is we're going to take our curve and we're going to shift it one place vertically, up one spot. So we're going to end up with an asymptote. Instead of being at y equals 0, it's going to be at y equals 1. My curve is going to come down and be asymptotic with my y equals 1, and it needs to be asymptotic underneath, and it's going to come down, it's going to be asymptotic with my y-axis. Okay, so we should have two parts of the curve drawn on. We're looking for this horizontal asymptote at y equals 1, and the mark schemes then divvied out the marks as follows. First of all, if we've got this shape of the graph in the first quadrant, we've got ourselves a method mark. Now it's really important, and the mark scheme, as always, is really particular to make sure that your curve does not do this. So if you've drawn your curve crossing this y-axis, then you lost the method mark. It has to be asymptotic, and I haven't done a brilliant job here, but at least it hasn't crossed my y-axis. Okay, as soon as it crosses, you've lost that method mark. Secondly, we needed to state, because the question says stating the equation of the asymptote, so I can either write that underneath or label it up on your diagram. Asymptote there, y equals 1, got you a B mark, so an accuracy mark, and the third and final mark, we were looking for the curve to be drawn correctly in the first, but also in the second and third quadrant. So it needed to be asymptotic with y equals 1 and the y-axis. So I needed both sides of those curves to be correct to pick up the final accuracy mark, and that was an A accuracy mark. Okay. Okay, second part of the question. We've been given a straight line, so y equals negative 2x plus 5, and we've been asked to work out any points of intersection between that straight line and the curve that we've already drawn. So look at what we've been given. It's got a negative gradient, negative 2, goes through a y-intercept of plus 5. So it's going to do something like, so a negative gradient, it could come through my diagram somewhere like that. It might come through and cut my curve twice, or we look a little bit later in the question, it might be a tangent to my curve and have a single solution. So depending on how my curve's been drawn, my values of k squared, I might end up with 0, might end up with 2 solutions here and here, or I might end up with a single solution where it's a tangent to my curve. But first of all, to find out what those points of intersection are, I need to equate my straight line with my curve. We were pretty good at doing this. We did minus 2x plus 5 equals k squared over x plus 1. Multiply through by x, I'm going to get minus 2x squared plus 5x equals k squared plus x. So I've got, remember my x squared over on the other side, I've got 2x squared, I've got plus x minus 5x, that's minus 4x, plus k squared is equal to 0. Double check that's what we've got in the question. So we've been asked to prove that 2x squared minus 4x plus k squared is equal to 0. We've got ourselves 2 marks. So we got 1 mark over here for equating our straight line equal to our curve so that we could solve and find our points of intersection, and then an accuracy mark for going through the steps to come up with the equation we've been given. The final part of the question asked me to work out the values of k for which the line is a tangent to my curve. So I'm looking for that solution. So what I've got is 1 point at which the line has a point of intersection with my curve. So have a look at the equation that we formed up. Got it over here. We've got 2x squared minus 4x plus k squared is equal to 0, and I'm looking for one solution. So I've got a quadratic in x. I'm looking for one solution. You've got to be thinking discriminant. You've got to be thinking b squared minus 4ac. b squared minus 4ac is equal to 0. So my b is negative 4, so negative 4 all squared minus 4 lots of a, which is 2, multiplied by c, which is k squared, and that's going to be equal to 0. So I've got 16 minus 8k squared is equal to 0. 8k squared equals 16, k squared equals 2, k equals plus or minus the square root of 2. There are a couple of other ways you could have done that. You could have had a look at the gradient of the curve, compare that with the gradient of your straight line. That will work through. To be honest, it's a lot more work than this method here. And alternatively, you could have looked at the completing the square on the question. That also would have got you through to a correct answer. But by far the easiest method. Have a look at your discriminant, put it equal to 0 because I'm looking for one root, one solution. B squared minus 4ac equals 0, and you can come up with your values of k plus or minus root 2. So with these questions, quadratic, single solution, 2 solutions, no solutions, got to be thinking b squared minus 4ac, greater than 0, 2 solutions, less than 0, no solutions.